Okay, so welcome to this morning session, which is can be thought of as the ninth class, but really more an introduction to applied digital intelligence track. One of the four, let's call it concentration or thematic tracks offered by BAScii program. Okay, so we have applied digital intelligence, which is kind of like solution looking for problems. We have smart cities and inclusive communities. We have health and well-being. We have sustainable development, and these three are more like problems looking for solutions. Okay, so it's not hard and fast. So if you study the problem looking for solution, that's not the solution will be within applied digital intelligence. If you study applied digital intelligence as a sort of a concentration, since the applied problem that we look at will come from those three areas, because those are the pertinent area of your education. Yeah. So without further ado, let's get going. Yeah. Right. So let me. Now this is one of those talk. Oops, what happened? Oh. Okay. This is one of those talk where I allow myself to use PowerPoint because again, it's very much a narrative kind of thing. So go ahead and start, and now we can do this. This is large enough, right? So we don't need to make it full screen. Can we make it full screen? Sorry. I can't see that little button. I think it's this one. There it is. Okay, good. Now notice I talk about applied digital intelligence. That's the heading, right? Embed within this, there's a little bit of a sort of like a hidden sign. Notice there's a little arrow here. So I'm actually going to be talking from intelligence to digital to applied. Yeah, so that's you see what I mean. Okay, quite a bit. So okay, first of all, there's a little, sort of like a picture play a slide. This is kind of a good way to start, and I tend to use this for my maybe consultant project as well. I need to consultancy is for lack of a better word, the success of consultancy sometimes depends on how well you communicate or educate the concept with your clients. So, they have a vague idea about, they want to use data science. They come to me and say, okay, can you do some data science on it? Okay, what does it mean exactly? So it's a good way to set up an alignment. There are a couple of words floating about. One's machine learning, one's artificial intelligence, one's quantitative models, and one is data analytics. And these are sort of like the orbits that I spend my well, not all my professional life, but certainly right now. Okay, so if you think about it, AI goes, in a way, goes further back. AI came from, after World War II or something like that. Okay, in fact, even before that, there's a, if you go back to, I don't know if you've been to Switzerland, if you go to animatron museum, there's actually a humanoid that does, signage or something like that. It's kind of early form of human mimicry. Anyway, the idea is this. Idea is you start with AI, which is a pure intellectual exercise. You say, computer can do a lot of things. Computer can add, multiply, help us do that. How about can it mimic our behavior? So in a way, in this case, and as you find out, artificial intelligence, in this case, the word intelligence strictly means human intelligence. Okay, so we consider ourselves to be the most intelligent species on this planet. And so artificial intelligence means something non-human that artificially mimics human, right? That's basically it. And you can say that AI, or artificial intelligence, motivates machine learning. What it means is that in order to build an AI, you can't really program it. Okay, there's some attempt to say program, all possible question or all possible answer and have this machine that answer everything. It's not possible. You can't have like a rule base. That's called rule based or classical AI. That kind of failed. And that doesn't scale well, right? So if I have a specific knowledge, like a piece of legislation, I can build all the if and if this then that, why this, why that sort of thing. I can build it as a rule. Okay, but when you scale up, it doesn't work. And you see, today it's kind of obvious now with the large language model, ChatGPT, you really can't program everything in. So you got to somehow set an algorithm for the AI to build itself. How does it do it? It does certain kind of learning, and all you're responsible for, okay, is coordinate this learning, coordinate the information presented in a data or whatever format that the computer can read, get it to read, and hopefully it learns. And of course, we have to program how it learns. So in a way, AI kind of motivates ML, machine learning. Having said that, machine learning as a field itself go well past AI. Okay, so you get machine learning that doesn't try to mimic human behavior. Okay, so you get, if you think about it, any kind of data analysis is setting your model against a set of data. So you can think of that as a general problem in machine learning. It has nothing to do with artificial intelligence. But anyway, once you get to that point where you have this generalized machine learning, it can start build any model. Okay, and the objective of that model may not be to mimic human beings. Okay, for example, one of the method is to say, well, how can we learn about this representation of a map so that you can find the fastest path or something like that. It kind of like helps build these quantitative models that analyze things quantitatively using mathematics. Okay, but it's not mathematics built by human being in a way necessarily, but it's sort of like we help get it going. But once the machine learns the mathematical logic of its own, it builds a model that we may not even understand ourselves. We know how it builds itself, but once it gets to a certain level of complexity, we can't really tell, okay, what this model is doing. But certainly we can validate it, good or bad, or error, or accuracy, and whatnot. Okay, so that's, in a way, machine learning is a foundation of building a lot of quantitative models, modern quantitative models. Okay, so you don't rely on human intelligence or brilliant mathematicians to build a model anymore, that sort of thing. And quantitative models here is powerful. One of the way it is powerful is that not only can it do high-level abstract mathematical operation, it doesn't get tired. So if it doesn't get tired, it's very good for churning, going with a large amount of data. Okay, so in a way, if you didn't have data, well, that's kind of irrelevant. But because the human society has been generating data, and we'll talk about this digital part later, basically we have so much data that we generate with or without knowing. Okay, so you really need this kind of quantitative models to, drive this thing. So quantitative models really drives data analytics, all the analysis that that I do professionally. And it goes back all the way so that data analytics kind of validates that we were right to try to do this artificial intelligence. Not because data analytics is better because AI can speak like a human. That's mimicry. But it's the whole research thing, whole mathematics, whole representation of reality into vector space, into something that you can put in as an input data, machine can learn. The whole thing has made data analytics so powerful. Okay, even though the original thing had nothing to do, people who were doing AI, I don't know if you've seen the movie like I think the Enigma machine, I think was called the imitation game or something, right? Alan Turing, I mean, he was not in the least bit motivated by doing analysis on e-commerce data. That was the furthest thing from his mind. Okay, but it kind of goes back, and this happens all the time. It happens all the time. Sometimes the loop is, or the arc takes 300 years, from pure intellectual curiosity to make money. Sometimes it's 10 years, sometimes it's 5 years. Okay. But this is one of those stories. Okay. So that's the setting. I gave you this thing because I included this glossary that has definition of various things. But again, we're going to go fairly quickly, so let's skip to this thing. Let's talk about intelligence. In particular, I'm going to start with this thing called computational intelligence. Okay. If you think about it, think of intelligence as a general concept. Again, you have to work with technology, you have to have the skill to code and all that, but you have to have the mind to understand what it is that we're doing. Well, there's three meanings of non-human intelligence, by which I mean intelligence that's not tied to the concept of being a human being. Okay? One, it's not human being, but it looks like human being. Okay, so it's human-like. It's understanding human, working with human, chatting with human, appearing human. So that's really the original foundation concept of artificial intelligence. Okay, there's also second meaning of intelligence. This is more borrowed from military intelligence. Intelligence here is a piece of insight, okay, that ordinarily is not revealed. So it takes a lot of work. Now, in military intelligence, the work that you invest can be paid in human lives, right? Send spies get caught, they get interrogated and tortured or whatever. But nowadays, if you don't talk about business intelligence, you don't talk about military intelligence, you talk about business intelligence, trying to extract hidden information or sort of like a non-public information. Okay, now you can't steal this. This would be like spying, right? But you can do certain things. A good example would be, for example, you monitor the activity of this company. This company is involved in, let's say, this office. Okay, in America, they don't just work in a big building. Sometimes they work in what's called industrial park. And so you can say that, well, hey, this industrial park houses this team that does merger and acquisition. And we know what the merger acquisition client they look after. Okay, I'm just making up some example. Okay, just say Walt Disney. This is not what happened. It's not the real case, but let's say the major client of this firm is Walt Disney or something like that, right? And you know that maybe 21st century Fox is having financial problems or something. Okay, and then you notice, okay, you monitor the pizza delivery. Okay, it turns out there's a lot of pizza delivery in the late night hours. So why would merger and acquisition people stay up late? It's certainly not because they have consecutive birthday parties. Chances are they're working on something big, right? So that's kind of like business intelligence. Now, you're not stealing anything, but you're being intelligent by extracting that kind of information into something. Hey, wait a minute, there's something, this merger acquisition thing going down. Maybe Disney is taking over or something. Okay, now I'm just making this up, but this is real case. Not with Disney and 21st century. The real study case is out there. If you Google it, some business fairly large event. Okay, just by monitoring the pizza ordering. Okay. Finally, there's the real meaning that I think I would start off today, which is computational intelligence, meaning that we don't really care about whether or not this looks human, but we want to get intelligent solution, cost-saving solution, efficient transportation route, okay, cheapest way of planning my logistics so that I can take coal from the mine, mix it, put it down a barge, take it down to the river, organize it, send it ship off, minimize waiting time, minimize waiting costs. So this sort of like better solution. So intelligence in this case means more intelligent than human being. Now, nowadays, I put the word bracket artificial here because this is what's happening. As artificial intelligence, in the first meaning of the word, gets so powerful from the data that we get, it's beginning not only to just act human, but it's beginning to give better solution or better answer than human being. Okay, so right now, certain things are just sort of like expression. For example, ChatGPT is not better at getting factual information. Okay, it's faster, but it's not necessarily more accurate or reliable. But what it's good at is phraseology, meaning phrasing everything. So you can think of it as a very good language or English language editor. Okay, that's what it's good at. And it's also good at sort of like feeling out bits of information. Now, whether or not that bits of information are the type where the global reach matters, like consensus or feeling, or whether or not it is a mathematical or something that can be calculated or computationally verified. The latter bit, of course, ChatGPT cannot do. And that's why ChatGPT has this kind of backdoor connection to Wolfram Alpha. Wolfram Alpha, in your software, you can access directly, okay? But if you don't access Wolfram Alpha directly here, you can pay you can pay ChatGPT Plus platform, and they allow you to ask ChatGPT to access Wolfram Alpha for you, okay? But while you're a student, you can access Wolfram Alpha directly. You don't have to pay ChatGPT Plus. Right. And so there's classically there's three areas of computational intelligence. One is, emulate. If you're going to mimic human being, right, in response, why don't you mimic human being computationally? And what's the computational engine of a human being? The brain. And that's why the first studies of the the 80s and so forth, even before I was born, you kind of emulate biological brain, and that's gave rise to the world of artificial neural network. There's also this thing that you don't have to worry about today. It's sometimes to find better solution, you can get inspired by nature. Nature does things by trial and error, but it's a guided trial and error. So your human biological evolution is a result of chance, but it's not pure chance. It's chance with directive. In other words, if your random mutation of animals leads to better fitness, that is maintained. Don't forget wear your mask. Okay? If it doesn't lead to better fitness, then you die. Okay? Wear your mask. I can't believe you don't get the message. Okay? Wear your mask or leave or get it somewhere else. Come on. Don't waste other people's time. I have no patience for this sort of thing. It's nonsense. Okay. Right. So this is kind of nature-inspired solution algorithm. You hear it a lot in modern technology, like swarm intelligence, things like robotics that drives autonomous drones, except it's not big drone. It's 300 small drone that coordinates. Okay, that's sort of like inspired by the way a swarm of birds coordinate. Okay, so there's no big bird that say turn left, turn right. So every communication is fairly local. Okay, you see me do something, you do something. You see me do something, you do something. For some reason, this propagate out as a network of communication, and you get all orchestrated behavior of a swarm of birds and bees and whatnot. Okay, likewise, you can do that with robotics. So this is a modern idea that's coming. And finally, you want to get the computer algorithm to operate well with human society. So this is where you have human feedback, haptics, cybernetics. In fact, a lot of what I do is grounded in cybernetics. Okay, fuzzy algebra is one of those things where you map human concept of hot, very hot to actual temperature scale. Okay, so if I have a recipe that say heat the cake up a little bit. Once it's warm enough, maybe add cream. Well, this cannot be turned into algorithm unless this concept of warm cake or puff up enough or a little bit soft to the touch cannot be translated to mathematics. Well, fuzzy algebra is what does that. Okay. In fact, my own project that I'm working on trying to get the international or intellectual patent is based on this mapping of the investment objectives. Anyway, so that's 3 areas of computational intelligence. Now, what's happening is the birth here, the artificial neural network here got sort of like turbocharged in the last 10, 15 years due to this computational capability, thanks in part to NVIDIA and people like that, who were making the game cards. Because artificial neural network, when you go inside it, there's a lot of matrix multiplication. Okay, the thing that we talk about, except they don't do just 3 by 3, they do gazillion by gazillion, that sort of thing. Okay, so that's why it's very important. Now, these are just example parts where I'm going to skip over that. Okay, so now we get to the idea that well, if an intelligent person, okay, human beings are not equally intelligent. Okay, some are more intelligent than the other, and by definition, we are more intelligent as a learned person, as an educated person. Okay. By the way, learning and education are 2 different things, but we'll talk about it later, maybe in the orientation day, right? But that actually, if you think about it, there are 3 modes of learning that you guys have put yourself through or been put through ever since you opened your eyes from your birthday. Okay, so 3 modes of learning. First, you look around, you observe, you associate a variety of things. Okay, whenever you see your mom or smell, first of all, if actually not see but smell, the smell of your mom is associated with warm milk, being nice, happy, warm, and everything, right? So you start associating, smell your mom with being fed, that sort of thing. Well, and then your mom again teach you to recognize and label things, right? So this is an apple, this is an orange, blah blah blah. You start to do that, right? So you pick up something and you say orange. If it's correct, your mom say good. If it's not correct, your mom say no, it's not good. So it's kind of like direct feedback, immediate feedback, right? That's the second stage of learning, and that's the sort of learning that you do a lot with babies, right? This is an apple, this is an orange, this is a cat, and when the dog come in and your baby go cat, no, that's not a cat, that's a dog, right? So now your baby start to learn distinguish cats and dogs. So these are kind of immediate I/O, picture comes in, the word come out. If it's correct, good. If it's not correct, bad, right? There's a right, wrong right away. Then you sort of like make long-term connection. Okay, you go to kindergarten, and if you sort of like play with your toys and you don't share, after a while you realize nobody likes you. Okay, these are long-term things. It's not immediate feedback. These are things that you have to learn over lifetime. Now you come late to class, I tell you off right away. That's good. That's easy. That's easy. That's direct feedback. That's like, come on time, good. Come late, bad. But in real life, that's not the case. In real life, what happened is you get hired, they have meeting, staff who comes late habitually with excuse, after a while, they don't give you direct feedback. They just will not promote you. Okay? Boys who show up late on dates, after a while, girls just will not come to date with them anymore. Now, they're smart enough is that to make this kind of long-term association. Being polite, being courteous, being respectful, being punctual makes you a more likable human being. Okay? People like you more, you get hired more, you get better position. I would certainly pick, if I have a consultancy project, as maybe even funded, I would look, I need some, I can't do everything myself, I look for students. Okay? Who would I look to? I would look to people who sit in front. I would look to people who show up on time, ask intelligent questions. Okay? Now, this is not immediate feedback. You don't get this electric jolt that you come in late and you get this electric jolt that you're not going to get a job. No, but over time, in a lifetime, you find out that you will underperform relative to your peers. Okay? Your peers will be picked out first, that sort of thing. So this is called reinforcement learning. Okay, oh, sorry, I haven't given the name. So scientists look at this. Okay, and they say this is how babies learn, this is how human beings learn. If we want to program an algorithm for a computer to learn from data, we have to do the same thing. So the first thing is computers look at data and try to make association between things that are close together, things that are not close together. And that falls under what's called unsupervised learning. Okay, it's unsupervised to the extent that computer just makes its own connection. Okay, it makes its own connection, just like you make your own connection between the smell of your mom and warm milk, right? Nobody needs to do that. Nobody needs to do that. Okay, a dog comes in associated with a loud bark. You don't like it, so maybe you don't like dogs. You know, when you're babies, if the dog barks too loud. These are not taught. These are picked up automatically just by association, by closeness. So implicitly, we are genetically programmed to have this kind of measuring distance. Okay, so smell of mom within 5 minutes, warm milk. Okay, now these are genetically pre-programmed. For example, and this we share with most mammal dogs, for example. If you eat something, so you eat some noodles, right? And you get sick. Now, you can have a delay, but your body will remember. So it doesn't have to be like you eat this noodle and you throw up right away, right? But maybe this afternoon you get sick, you throw up, you have diarrhea or something like that. There's a distance in time that makes an association between this noodle shop and you going to the toilet uncontrollably. Okay, that is a pre-programmed capability, and this association. Once you have this association, you can learn any association, right? Between arrival of signal and consequence, signal, consequence, signal, consequence. This kind of association is called unsupervised learning. So basically, just give it a data set. Second thing is when you're taught this is an apple, this is an orange, this is a dog, this is a cat. That's the bulk of machine learning that you do today, which is called supervised learning. You have an input and you have an output. An input is pixel picture, pixelated picture. Again, what's a pixel? What's a picture? What's a digital pixel? It's a tensor, right? How many pixel Y, how many pixel up, and then multiply by 3, right? Because you have red, green, and blue. So you pass on this tensor, that's the input. The output is it's a cat, it's a dog. Okay, now you can have tensor with another dimension, which is time, in which case you're feeding video data. Okay, so where on the screen on the horizontal axis, where on the screen on the vertical axis, color red, green, or blue, and timestamp. Okay, timestamp. So then that will be your input. And the machine is, before the machine learns, it doesn't make automatic association. You have to give it association. This is a clip of a cat running after a ball of yarn. Okay, that's what we have to do. And reinforcement learning is a little bit tough for you to get your head around. But for those of you who are interested in the part of applied digital intelligence has to do with robotics, it's a little bit like that. Just like when you're a kid, if you play with your toys, if you don't share, nobody likes you. Okay, as long as nobody likes you is a motivation, a negative motivation, and your friends like you, that's a positive motivation. This reinforce behavior. So what happened is, if for example, I don't program the autonomous driving car to turn left or right, but I tell you this. I say, well, if you keep bumping into things, it's going to feel pain, right? But if it navigates quickly from point A to point B without hitting anything, it's going to feel pleasure. Okay, and I give it sensor data. Okay, so basically, again, sometimes I refer to Buddhism. This is sort of like the ขันที่หนึ่งรูปขันที่สองเวทนา right? As long as you feel sensation that this is bad, oh, I hit the wall. That's not good. I don't like this. Okay. Oh, I go fetch an object. Good. I'm happy. If you have this thing and you have this kind of long-term association, you start to build behavior. So the result is not a classification, but is a environmental interaction model. Okay. So that's called reinforcement learning. Okay. So that's how, again, It's motivated by trying to mimic human being, but ends up doing something a lot more powerful, a lot more intelligent. Okay. I just give you example. You know, this is not data analytics class. This is one of those things where, you know, you kind of draw this clustering, how things are together. You know, like I right now, spatially, I can say there are 4 clusters. There's front right, front left, back there, and back there, or something like that. Right? In fact, when I grade students, okay, now certain grade is sort of like an absolute scale, sort of like outcome based. So if you can do this, you get an A. If you can do this, you get a B. If you can do this and that, you get an A. Okay, but somehow it's sort of like a relative learning. Now, in the old days, you would say something like, you know, 95 is A, 91 the B. Well, I can do this in one dimension. I can get you grades, and there's a lump here of, you know, really lousy student, and there's sort of like middle bulk here. So maybe there's a C cluster, B cluster, and A cluster. And I actually do that. You know, when I need to do a grade, I don't do what's called bell curve. Okay, bell curve doesn't really work with academia because you guys are not homogeneous. Okay, bell curve works for a homogeneous population. You guys are not homogeneous. Some of you are more alert. Some of you are more conscientious. Some of you just here because, you know, your dad and your mom say you have to get a college degree. Okay, so certainly it's multimodal. Your grades will be multimodal. I've never seen BAScii student that has a grade like this. It's always lumpy. Okay, and so obviously, where are the lumps? Am I gonna use my eyeball? Yes, I can. Okay, but I'm lazy, so I use a computer. I use Mathematica to do the clustering and say, okay, this is the C cluster, this is the B cluster, B plus cluster. Okay, just use a fine cluster algorithm. So this is kind of like association. This is sort of a classical. Now, you should go to here, by the way. These are brilliant. 3 blue, 1 brown. You know, I'm talking about interactive mathematics. This guy is interactive, visualize anything, any kind of concept, except he did it for you. So it's not, you know, just manipulation by knobs. So it's kind of like a picture, a kind of moving picture. So this is how you learn things. Well, say, okay, this is supposed to be a 4, this blah, blah, blah. So most of object recognition is done by that. Something I use to teach machine learning. This is to show you that the foundation of neural network is based on this. Okay, it's based on the fact that the brain is made of 1 trillion tiny silly little thing, and that silly little thing can only do this. If I don't get a lot of signal, I don't say anything. If I get signal, I yell, hey. Okay, and my head goes to another neuron, and that neuron listens to other neuron. It gets enough hey, it goes hey, and just keep going. Okay, if the neuron doesn't get enough hey, it doesn't get activated. That's it. It's almost Boolean. Okay, but it's not quite. It's after all, it's biology, but it's this thing. It's this function. Now, with just 2 neurons, with just 3 neurons, you get something complicated, and that's how neural network learns, by tuning this thing. Except it's not just 3 neurons, right? Now, the human brain has what, 1 trillion? 100,000 million. Yeah, so that's what, 100 billion or something. I think if I'm not mistaken, don't quote me. Nowadays, well, that's still too much for a computer. But if you look at ChatGPT, right, that one also has millions of neurons. Okay, has millions of neurons. It's not as many as the human brain. I you know, don't quote me on this, but maybe somebody should say, you know, how many neurons ChatGPT has. Maybe it's about a rat. Okay. The only thing is, it's a rat that doesn't get tired, so it can read the entire Wikipedia page. Okay. So this is also, you know, double click on this, and this is all. I'm just going to skip it. But you know, there's always a certain thing. Now, when I said that once this thing gets built, you don't really know nitty-gritty detail how it works because it's not expressed as an equation, but you can control how well it works. You can validate it. And this is a very nice picture I downloaded from the internet. I forgot why, but you know, you can find it. But you can always be wrong in 2 ways, right? Okay, you can be okay. So a lady comes in, she's pregnant. You say she's pregnant, right? That's good. That's positive, right? Accurate, positive, right? You can also be right negatively. The lady is not pregnant. In this case, the picture is a man, so a man can get pregnant, so you know what it means. So the man's not pregnant, you say it's not pregnant, fine. Okay. Conversely, you can have the other two kind of error, type 1 and type 2 error. The lady is pregnant, you say it's not pregnant. Okay. Boy is not pregnant, but you say, well, you're pregnant. Right? So these are the four kind of what's called a confusion table. These are kind of like statistics you can control. So as data scientists, you don't particularly control individual neurons. It's impossible. That's the whole point, right? But what you control is you monitor this and you have the computer minimize the error. Okay, you have minimized error. So if you think of error as a pile of junk, okay, think of it as a hill. Where would you want to do? Where would you want to be? You want to go downhill, right? Because if you're up here, there's a lot of error. You want to go downhill, right? Okay. Well, how do you go downhill? Well, I tell you what. Imagine you're on top of a hill. You want to go downhill, but it's all dark. You can't see where you're going. Okay. What is the smartest thing to do? Any of you? You put your foot out and find the direction that goes down. And you go there. That's a clever thing, right? Well, in the dark, there's nothing you can do. Well, if you think about it, when you take this kind of short distance and find out which direction goes down, what's that got to do with calculus? It's evaluating the slope. Except you don't have just one direction, you have n-dimensional direction. So you use multivariate calculus to minimize the error. Okay? You do that, you tell the computer to minimize that error set. In other words, minimize this. Telling a man that he's pregnant, telling a pregnant lady she's not pregnant, and you want to maximize the probability that, yeah, when the lady is pregnant, you say she's pregnant, the man comes to say, no, you're not pregnant. Okay, so positive, error, negative error, and all kind of stuff. This is just to show you, by the way, that this is how easy it is to build neural network model in Mathematica. Again, top level model. Yeah, you building a neural network creates. You have to say like how many neurons you're going to have. If it's too much, the computer dies. If it's too little, it doesn't do a good job. That sort of thing. So there's a lot of art. There's a lot of loop, trial and error. So forget it. Okay, just say classify my data. Now, in this case, it's actually the same method. It's a neural network. You can actually omit that, and it will try to find the best. Okay, but sometimes you want to, that you want to work with neural network, and you want to minimize the looping. I don't want it to try something else, so I can specify. But really, you just need to say, make a classifier. That's how easy it is. Okay, so this is about 50 lines at least, but not 50 nowadays, about 15 at least lines in Python, whereas in here. Okay, so it's a little bit like that. Here's the data. Now the two kind of problem. They call it predictor and classifier. Basically, it is about the number scale. And I asked you like a quiz, right? I told you to remember ordinal scale, nominal scale, interval scale, ratio scale. The nominal scale and ordinal scale, right? And then interval and ratio. Well, if you predict cats or dogs, you can't say cats are better than dogs. So basically, a classifier is a neural network or AI or machine learning or algorithm that give me an input, give me a picture, and I'll output names. So I'll output something that is, well, numerically, it's equivalent to a nominal scale. Okay. Whereas if you want to say forecast the temperature, that's numerical stuff, right? Numerical stuff. I want to say predict level of rainfall tomorrow to an inches or something like that. Then you have 0, you have all the way up to, I don't know, maybe 100 inches a day or something like that. Okay, it's called predictive, but essentially it's all supervised learning. So there are other way of doing things. These are, this is the matrix called confusion matrix. Basically, you want actual and prediction to be the same. So you want the case count to be sort of like on the diagonal. So if your actual is like this, you pick something else, or the actual is like this, you predict this the off diagonal. So if you see this picture, just look by the heat map alone. Yeah, by the way, heat map is a matrix plot in Mathematica, right? So that's easy. You basically want to see diagonal highlights. Okay, so that's good. That sounds like good, right? So here, the training algorithm based on stochastic gradient. Stochastic gradient. We said the word gradient in this case comes from calculus. Yeah. If dy dx, now if y is a function of 2x, the gradient is dy dx1 and dy dx2, basically. Okay, so it's the direction of decreasing. So that's why you need calculus for this. Now, because it's already programmed, you don't really need to code that yourself. So it's kind of nice, but still the name is from that. Okay. Convolutional neural network, that's sort of like okay, when I was a student, okay, the mathematics was worked out. I can do a lot of forecasting prediction, but we couldn't do very well with image data. We couldn't do very well with image data. We tried to do what's called image filter. Now, again, I'm not making this up. Image filter is nothing more than matrix multiplication. Okay. Now, the difference was in my days, we were trying to apply set of filters to sort of like extract information from a picture and then feed it to a neural network. The difference with convolutional neural network just basically comes down to this guy. The filter themselves can be learned by stochastic gradient descent. So instead of just tuning the neuron, you tune the filter as well. That's what convolutional neural network is, because the convolutional refer to what's called convolution matrix. So basically, it's the matrix that multiplies the image value. Okay. When I was your age, this was all fixed. This was done by image processing computer scientists. But now you let the computer pick out the best. So it's going to highlight, it's going to pick out, originally it's got a lower level, it's going to pick out vertical line, horizontal line. Pretty soon it's going to know that if you have a vertical line in connection with horizontal line, maybe it's a building, it's not a dog. If you have something that's more smooth, maybe it's an animal, and then you figure out, where the eyes are and so forth. So these are successive level of complexity. Okay, so that's and this again is from okay. So the idea is that's what you have to do. You have to build intelligence. Now, second word is digital. Where does that come from? It comes from the fact that we talk about digital economy. And what do I mean by digital economy? I mean the fact that everything is digitized. So the difference between you and me, by the way, back then when we were doing, say, a PhD thesis or, even PhD thesis, sometimes you have to sort of like survey data. Marketing, for example, you see people with a clipboard and go ask, what's your opinion on this? What's your opinion on that? Why? Because the data is not there. So you have to so record it, right? And then key it in Excel and put it in computer. Nowadays, if you were to do the same kind of marketing analysis, you would just look at lock-in data. So the behavior doesn't have to be spelled out. Do you like to go to Siam Square, or do you like to go to Siam Discovery? Okay, I don't have to ask, because your position tells you where you are. So think about it. Your life has been digitized. Your life is on platform. Okay, that's what we mean by that. Okay, so it's no coincidence. So two things happen why we have this blowing up of AI. One's computational power, but computational power without data, right? It's not gonna have so much thing to learn from. But now you have this automated data scraping and all that. So it learned from that. Yeah. This is kind of like things about Bitcoin and blockchain. Blockchain is also part of applied digital intelligence, in particular the digital part, the aspect that has to do with how do you put information on the internet such that it cannot be cracked. If it's cracked, you know it's tampered with, you know, like make a seal. So this is kind of securing. It's going to underline. It's going to be the basis. In fact, this is already working. Every time you order things online, you don't send your Visa card number or your account number. What happens is that gets encrypted, sent over, and only the intended recipient can uncode it, decode it, and get the information. Okay. And so this is by the way, this I wrote this in Mathematica as well. This is kind of like cryptography. Remember, I told you that in life, you always have three situations: problem that has no solution, problem that has one solution that's in school, and problem that doesn't, that has multiple solutions, and you have to find the best. Well, if you're a hacker, your problem is to find one solution. If you found that solution, you hacked it. Okay, that's what hacker does. And this is a mathematical program that shows you why it's difficult. Basically, it's a mathematical equivalent of saying that it's easy to take eggs and beat it so that egg white and egg yolk mix into a kind of light yellow. It's much harder to unscramble eggs into white. Okay, that's what it means, basically. Okay, so information. Yeah, there's a second part is information. Again, your life is online. This is a long time ago. I did this for not for fun. This is actually, you know what this is? This is a graph representing a Hollywood movie and actor. So right here it says something like Toy Story, and these are the actors. Okay, and this actor then have movies and so forth. Now, based on this is what it looks like. This is real. So this is movies. These are the actors, or the other way around. I'm not sure. Yeah, there are more actors than movies, obviously. So movies, actors. These are connectivity, and this is what it looks like in real life. I downloaded this data from something for fun. Okay. Well, it turns out you can do analysis on this because the data is online. Okay. It's online. By the way, it looks like this. I can do what's called centrality analysis. Remember the eigenvector centrality? I can actually tell you who is the most important actor because he acts in a lot of movies that has a lot of good movies. And I would expect it to be kind of like smooth. It turns out it's not. It's really weird. This is anomaly, but it's not anomaly. It's verified by real life. There's one actor in Hollywood that is more connected, okay, than anybody else. So you know, this is our A-list celebrity. You know, if you read down all the names, this is our A-list celebrity. But even among A-list celebrities, there's one guy, okay, who stands out. Okay, you wanna know who it is? Okay, right. So finally, it's not just platform information; it's also device. And this is by the way, if you zoom in, this is old technology. This must have been maybe not 10 years ago, but many, many years ago. What I could do was I wear a thing, which is GPS, right? And there was a biathlon, basically, you know, BAScii, right? Rayong, you know, Got Samet, right? Okay, well, anyway, took a ship down to Got Samet, right? And 10 of us swam back from Got Samet to BAScii. Now, it was actually a competition, and I was dead last, almost dead last. The point is, at that time, and this was fairly new technology, was GPS. Except the GPS didn't work underwater, so I had a little trick. So I put the watch inside my my wet cap, my swimming cap. So I get it's kind of guaranteed that my head is somewhere above water. So because I'm swimming, you know, front crawl, so the satellite can pick up. So obviously what this informed me is that one of the reasons I swam really slowly, in fact, it took me 4 hours, was because I was swimming in a curved line. Okay. So that tells me, hey, work on your sighting. Work on your sighting. Now, it could be because of current. I don't know what it is, but certainly I was very slow. Okay. Likewise, I was taking like a paragliding lesson. Well, paragliding lesson, it shows you how well I control my figure of 8. Well, figure of 8 is when you're trying to land. So basically, you turn off the engine to land, so you glide down, but you can't just go boom like that. So what you do is you pick a location and you sort of like circle your way. So this is how well or didn't do well, how not well I did my figure of 8. Okay. So your performance can be monitored, right? Right. So if I had a coach, if this were like a national sport, like a precision flying or something like that, instead of having a coach and say, oh, you're flying, you can look at this data. Okay. And this is done for anything, motor racing, boat racing, yachting, all kind of stuff. Okay. So this is the fact that everything about you is digitized. This is a screenshot, I think a heartbeat or something like that. And this, of course, is Garmin. This is from my, I think it's a half marathon at Kanchanaburi. So for 35 kilometers, it knew exactly where I was. Okay, so that's GPS, nothing interesting there. But it also knew how fast my heart was beating. Now, here's a clever thing. This is something that I don't know if you can see it, but there's a line that says something about the strike length. There's a line that says cadence and vertical oscillation. What it does is this. If my Garmin watch links to the GPS, it can calculate the speed and position. That's easy. Well, not easy, but you understand that. But you know what it does have? Just like your iPhone, by the way, it has accelerometer. Accelerometer means that as I'm running with my watch, let's make this a smartwatch. There's an accelerometer, right? Down, okay? And an algorithm was developed to infer movement of my arm so that it can tell us that at this point, I am in the air because of certain interaction with gravity. This point, I'm hitting the ground, right? It can actually impute backward over the course of 35 kilometers how much time my feet spend in the air. Think of how cool that is, right? Think of how cool that is. So that's why all this data is digitized. It's digitized. This is ground contact time, vertical ratio. So it even knows that, if I'm running inefficiently, I'll be popping up and down a lot. But efficient runner just kind of like looks like this. Looks like they're gliding. Okay. So I know this. I try to do this, but this is a direct feedback. I say, oh, wait a minute. I had terrible vertical ratio. So in the beginning, I had a lot of energy, but I wasted a lot of energy. It turns out toward the later, maybe halfway back, I was running more efficiently. Well, actually, it was more because I was so tired of doing this. Okay. In the beginning, I was energetic, but I was wasting so much energy, jumping up and down, jumping up and down, jumping up and down. My style was bad. My style was bad. Okay. Finally, quantum computing. We'll talk about that later, but it's a very interesting thing. There's a good. But anyway, this is actually real. This is a screenshot. This was way back, I think 2018. IBM had a 5-qubit quantum machine that it say anybody can play with. What they mean is that they have like an interface that you can go in and sort of like write in your code. I just use a hello world kind of code, send it to them, they put in the queue, they calculate, they give back the result. So this is the interface. Now it's a lot more sophisticated interface. They actually have a programming language for Qiskit. Okay, so this is very advanced. Obviously, quantum machine in theory can crack code. Okay, not yet. It's going to take quite a bit more qubits to do that. Okay, so let's go back to apply. Okay, so again, intelligence, the meaning of intelligence, how it interrelates. Okay, go back to sort of like feeding one another. You can't have intelligence, you don't have data. If you have a lot of data, you can't process it, you don't have intelligence. Fortunately, you have both intelligence and data. And why do you have data? Because your life is digitized. Okay, your life is digitized. That's why when they say, human beings are creating more information than they ever did. What they mean is digital information. They don't mean that we write more. We certainly write a lot less book than we used to. Okay, it's not like everybody's writing more books. Okay, but that's what's happening. That's what's happening. Okay, so let's look at apply. Now, in this case, there's this thing, and that thing. Now, have you sent my message to the group? Do it now. Okay. I'm actually in my second kind of thing. One of the things I was working on very actively around 2015 to 2018 was in sustainable development. Okay. So today I'm going to give you a heads up on applied digital intelligence. You will have your day with sustainability, sustainable development. But because I did a lot of work in that, if I had time, I would go over it, right? But today I probably won't. So I'm just going to send you a link to YouTubes and papers and stuff that has to do with sustainable development on its own, okay? Now, sustainable development is one of those areas where it's ripe for application of data science, okay? It's no good to say, oh, let's plant a lot of trees, okay, unless you understand. For example, okay, you want to plant trees, right? You want to plant trees, okay? Do you know what kind of trees you should plant? And that's a matter of data and science, right? And data science and science, but data. So, for example, what kind of trees are able to grow over a short period of time and sequester a lot of carbon? Okay, different regions, different. Okay, there's some scientific paper about what happened in Africa, what kind of trees in the Amazon, what kind of tree, what kind of leaf, green leaf, short leaf, big tree, small tree, young forest, new old forest. Who's better at sequestering carbon? Who? You don't know. Okay, so all this is scientific data, but they're not coordinated. Okay, so that's what data analytics will help. But anyway, I'm not going to go back to it. I want to go back to the full screen. Oh, this is sorry. Okay. Before I go, I think there's a slide that I want to show you. So this is kind of like a schematic spread out of the group of subjects that we are planning for the applied digital intelligence track. Some of it is focusing on intelligence, being machine learning, artificial intelligence, optimization. Again, optimization has to do with finding better intelligent solution, not necessarily human-like. So it's not a chatbot thing. Okay, and then you have this thing about the digital platform again. So this you have IoT, distributed system, robotics, that sort of thing, and then application. Now, because we are part of BAScii, the area of application is just going to focus on the other three problem looking for solution. Okay, so the problem looking for solution. Now, in this slide, just going to skip over really quickly. Give an example of application to health and well-being. But this is already an application of health well-being, right? Right. This is my feedback exercise machine and so forth. Okay, but this is more specific. Okay, for example, this I just kind of took from a talk I was giving to a university. Basically, you can apply this to agro industry. Okay, again, I was talking about this what kind of tree is good at carbon sequestration, but also predicting yield. And this is done, by the way. Why? Well, just like your life is digitized, so is farming. In America, when tractors go, they actually drive themselves now because they have for a large farm, not a small farm. They have a GPS coordinate that say this is the sort of like the end of the thing, and just program the tractor to drive, turn around, so you don't even have to be there. okay? Because it knows the coordinate. Well, that's not the interesting bit. The interesting bit is that because you have this kind of geo positioning, you can hook up your sensor, soil temperature, humidity, wind speed, all kind of stuff, and you can feed it live. So you actually have a live, maybe not live, but certainly data bank of all this temperature, humidity, soil, acidity, right? All this uploaded, right? Now, so what happened? Well, America wants to grow corn. Well, they grow a lot of corn, but they always want to grow more corn, okay? They can actually predict corn yield based on factors, right? Now, depends on how you want to use it. If you're in a financial business, trading commodities, you use this so that you know, you try to have an idea of where the price of corn is based on production. But if you are sort of like the farmer themselves, then you certainly want to use this to manage your field. It's very possible, and American farmers are not poor; they're rich. They have huge land. Different part of their lands actually have different weather system. Okay, it's not just obviously certain part has more soil acidity and humidity, but it's almost like they have such a large land, they have different weather system. And so all this model is going to tell them that this year or based on this condition, this is where I should do soybean. This is where I should do corn. Not random, not random. Okay, we're trying to do that in Thailand as well, but certainly it's there's not much commercial value at stake to put in there. So all this thing about corn yield prediction, soybean prediction, it's all American paper. Okay, so you see, this is all the, it's called the sort of like Midwest, Northeast, Midwest. So it's all corn. Bioinformatics. This is something that I hope BAScii students really think into, because this is really where we come in. Why? Because you don't really have that much access to agro industry. Maybe some people will, okay? Maybe your parents work for Beta Grow or whatever. But certainly, you are very close to one of the leading medical institution in Thailand. It's Chulalongkorn University. We have medical research, and they always have data. Okay? Health is all about managing. Well, it's about delivering the healthcare to the people, to the patient. But how well do you do that? On a micro scale, on a one-to-one scale, well, you have a good doctor, that's good, right? But on a health system, health delivery, it's not about individual doctor. It's about the population health. It's about population susceptibility. How much are we affected by COVID? How much are Thai people affected by COVID? How much are Thai people affected by non-communicable disease, like being lazy? Okay? How do we deliver that? What's our demographic? Do we have enough doctors in geriatrics, treating old people? Do we have enough doctors that deal with immunology, about disease and immunology? So anyway, so this was actually, I have my channel. It's just for academic. It's not for commercials. It's not. But COVID analytics is based on that. Taking information about input, current rate of effectivity or how well the disease spread, and then make a forecast. Okay, so you go look at that. So this is bioinformatics. There are other works in bioinformatics that focus more into things like computational biology, about the genetic. Okay, now this is where I tell you, if you're going to go into this, the best language to pick up, aside from Mathematica, is not Python, but anybody remember from my first class? R. Okay, because a lot of genomic research program all the algorithm in R. So if you're going to do genomic research, go in R. Okay, all these things, all these programs are done in R. Basically, why is life complicated? Well, life is complicated because it builds on simple instruction but a lot of work. Okay, think of it this way. By the way, this is central dogma molecular biology. This is something I think every human being or every college graduate should know. This is how human beings work. Okay, your DNA is like a code. Okay, code. but it's not what drives your life. DNA doesn't make you who you are. DNA is a set of possibilities. It's like a recipe library. Okay, recipe library. Now, what gets decoded? That's called epigenetics. I'll come back later. But the point is this: everything in life happens when your cells make protein. Okay, and there's a process of making a protein is like going to a book and say, okay, how do I make this protein? Let's make it. Okay, and that governs your life. Some people have problems in health because they keep making the wrong kind of protein. But the point is this: how does protein becomes life? Well, basically, these are the 4 steps. You can think of it this way. The proteins are like strings of beads. String of beads, okay? Think of it, string of beads, okay? And there are 20 kind of beads that you can put on a string. And because the string is kind of magnetic, it's not magnetic, it's chemical. It has attraction to one another. So each bead has a different shape. Okay, maybe electrons sticking out here, electrons sticking out there, blah, blah, blah. So based on the sequence of protein, you have sequence of different relative attraction, chemical attraction. Think of it as magnets. What happened is, what if you have this string, right? And you let it go, boing, it's going to clump up. It's going to clump up according to relative attraction. Here's the deal. If it clumps up and it looks like a knife, it works like a knife. If it clumps up, it looks like a cup, it works like a cup. And that's why all the biological function in life depends on the sequence, because the sequence determines the relative electron or chemical attractiveness. That in turn makes shape. And sometimes it's not just one protein, it's 3, 4, 5 different proteins get together and make a basket. One of the basket looks so nice that oxygen likes to go and sit in. So it becomes heme. That's what carries oxygen to your blood. Hemoglobin, all that stuff, right? So you're going to learn about design, right? This is one of those things where the ethos of design is what? Form follows function. But when you get down to the biological level, function follows form, right? If the protein comes up and looks like a bowl, it's going to carry something. If it cuts up like a knife, it's going to chop something. If it comes up into a tweezer, it's going to bring 2 things together. That's what a lot of enzyme does, kind of put things together. This guy and this guy, they can be together, but they don't get matched. It's like playing a match. So boy and girl, they would like each other, but right now they're too far. They don't trust each other. But there's a third guy that this guy likes, trusts. This girl trusts this guy. So hey, come to dinner, and I'll match them together. And the boy and girl get married, whatever. Okay, the one that does this is going to look like a tweezer. It's going to look like something like this. All right. And how does it look like this? Because of the sequence. So biology determines function. The sequence determines function. Okay, function follows form, and then you have that. And then you have a whole bunch of action. Now, the difficult thing, here's where it comes in. I've heard this when I was just graduating. I was finishing my PhD. I said, if I had to do PhD all over, I would try to work on this problem. And that problem is called protein folding. This boing process that I told you about is called folding. It's very difficult to predict. Extremely difficult to predict. Okay, what happened when electron and positive, well, electron and positive ion comes together. Well, that's going to be a track, right? Negative ion and negative ion, they're going to be far apart. But again, the protein have a number of it's a molecule, right? It's a whole bunch of molecules. Some molecule has this kind of negative here, there. This sequence of molecules here, how's it going to come together? Very hard to predict, very hard to forecast. Now, here's a funny thing. Using machine learning, and it just sort of like guess, but it makes a good guess. This is how cool that is. This is how cool machine learning has become. And this is where it's no longer trying to talk to human beings like, you get excited about chatbot, whatnot. That's all silly stuff. This is where it gets exciting. It's cracking a problem that engineers, scientists, mathematicians, computer scientists have had very difficult time cracking. Okay, so this is why you read about this AlphaGo playing the Go. Well, it's AlphaFold. That's the exciting thing. That's what excites me. AlphaFold. Okay, so they actually study protein folding from looking at patterns. It's sort of like, if you have this kind of sequence of molecules, this protein looks like this, it's going to look like that. It's something like that. Okay, so I may have been inaccurate in terms of biology of, where does the protein lie, where does the shape, but it's roughly that. What I'm saying is correct. Okay, the idea is that it's very hard to predict the shape, so it's hard to predict the function. So it's very hard to engineer the function. This thing, when you see the word expression, that is sort of like gene is like a library, like I said, and you have to go and look up different protein or make different protein. Expression is the decision on how to express those recipes. So some people have genetic disease in the sense that doesn't have the gene to make a certain protein. Well, sometimes everybody has the same capability. But for some reason, for this guy, keeps making the wrong protein. Okay, they got the same library, but keep looking up the wrong book. Okay, so that's kind of like gene expression, gene expression, regulation, epigenetics. These are sort of like words that circulate around here. Now, I'm not precise enough in my understanding to sort of go deeper into that, but that's what these are all about. So gene length expression. So these are. This, if you look at this paper, you say that they shared code and it's all in R. Yeah, it's all in R. Yeah, this is R code. Yeah, that is good. Okay. And of course, this is it. This is gene sequence, right? You read the gene, you make the molecule, you make the molecule, make the protein, make the structure, so forth. Okay, so that's that. So tertiary structure, that's once you get, see, it already becomes a shape. I don't know what this shape does, but that's certain thing. This is finance. I was giving a talk to PyCon Thailand. So this was 2019, so it's pretty dated. But you see the word fuzzy here? And I use that to map between investment objective and mathematics. Okay. I kind of had this implemented, I think, with Python and Mathematica. So obviously you can see that this is my manipulate screen, right? That's what so the Mathematica code is very, very powerful. And it come up with the solution, so forth. Linkage, that's I'm gonna talk this is what I use for my professional life. I literally use financial data, and instead of searching over the distribution, all this graph, all this plot are found. Okay, are found. If you look at the bottom line, it says something like distribution. This is found by find distribution function in mathematics. So this one here. Now, if you learn finance and you talk to your friends in business school, in economics, they're gonna come running to you and say, stock price are distributed normally. That's what they're taught. Nonsense. Okay, well, actually, it's known now. Well, maybe they don't teach that anymore. But in the old days, they would say stock price have normal distribution. It actually has, for this case, this is not stock price, but financial variable are like this. So this would be Laplace distribution with the parameter here and there. This is student T distribution with mu, sigma, and degree of freedom 2 point something. So this is done automatically in Mathematica. And so this is kind of commission research. We will pay a lump sum of money to hire a student or whatever, and run data on financial market. In fact, I'm going to have a talk on this particular project to the Bank of Thailand on the August, if not the 8th or the 9th. I think it's a Wednesday, I'm pretty sure. I think it's the 9th. I can send you a link later. But anyway, it's connectivity between different markets, because Bank of Thailand, they're interested in how economy moves. And certainly there's inflationary pressure from outside. It's a way to predicting data. Normally the conventional wisdom is that whatever happened in the United States drives the world drives Asia, Asia drives Singapore, and Hong Kong drives Thailand. Where it turns out that the real interactivity is more complicated than that. So it's not just one way down like this. Sometimes our market move ahead of other people. Okay, that does happen. So this is interactivity. Basically, this is connectivity. Okay, so good. My timing is pretty good. That gives me. I'm very happy to talk to you guys, because after all, that's my way of giving back. When I was your age, I had nothing but enthusiasm to learn, and respect for the subject, respect for the teacher, respect for my friends, respect for the body of knowledge, and the eagerness to learn. Okay, I learned a lot when I was an undergraduate. But the most important thing about my undergraduate education is that I learned this lesson, that there was so much more to learn. And I was the architect of my learning. The only thing I cannot control what the world does, but I control my portfolio of effort. Okay, and I use it wisely. And a lot of things that I rely on, even professionally, came way after I finished my PhD, not even undergraduate. Okay, this thing about Coppola, this thing about network thing that I told you that I was the first person in Thailand to apply, I didn't use any of that when I was a student, not even PhD student. Well, I'm using something for my PhD now. It just happened to be I go back to reach out to that, but it's not. It's all about lifelong learning, guys. So if you think you are here for 4 years to learn a skill, to get a job, you're in the wrong school. Quick, sign up for Polytechnic. Okay? If you want to learn a particular set of skills so you can get a job, you're in the wrong school. Okay? You're here because human beings are most practical when they're most theoretical. Because when you're theoretical, you can apply to a larger class of problems. If you're only practical for one thing, you're a technician. This is not a polytechnic school. It's very important for society to build a lot of polytechnics, people with skills, okay? They are going to be much better at a particular set of skills than you are. So if you're here for a set of skills, you're in the wrong place. And when you graduate, you wouldn't be any good. You'll be outcompeted by people who focus their 4 years on honing their particular set of skills. Okay, that's not going to be your strength. If you hope to do that, you're in the wrong place. But if you understand that learning is a lifetime process, right? You're here to learn the foundation. Okay, mathematics, science, biology, chemistry, language, coding, programming, algorithmic thinking, algorithmic computer architecture. You're going to have some tools, programming, Mathematica, Python, maybe R even, right? Prototyping, 3D printing, 3D scanning tools. Then you're going to deepen in certain areas that are multidisciplinary. You can't deepen in one area that somebody else is already learning in other department of Chulalongkorn. So, you can't go in genetics, be deeper than biologists. But certainly using bioinformatics to solve genetic optimization or modeling or prediction, and that's something you can do better than other people. That's your deepening skill. And then you have some practicum. Practicum is not about trying to get a job again. Even project learning is not about project. By the way, I ask you to bring your parents to the orientation day so they actually have a good understanding of what to expect. But one thing right away you can tell them, the school will try to implement project-based learning. The outcome is not the project. The project is used as a vehicle. Occasionally, those projects happens to resonate well and just catch on and you can spin it off with startup. But BAScii is not in the business of producing startup. Okay? You learn by going through that startup, project-based thing. And you learn to fail, you learn to succeed, you learn to communicate, you learn to work as a team. BAScii is not a startup manufacturer. If you think you're going to come to BAScii so that at the end of the 4 years, you and 5 of your best friends will have a successful startup that come out of BAScii, you're in the wrong place. You're in the wrong place. Okay? But startup, project-based learning, this is going to be very much part of your daily lives because we use that as a vehicle. Okay? So anyway, I'm going to make my way. Okay? Hopefully, you will get a lot from next week. Now, the Ajahn from this tech is going to keep things relatively light. So it's going to have that feeling of a sort of like summer camp, hackathon kind of thing. Okay? Which is good. But I don't think that's the life of a data scientist or anything. Okay? So would be nice. Can you make a little voting? I would like to put a vote. There are 4 concentration, right? 4 concentrations: applied digital intelligence, smart city and inclusive community, health and well-being, sustainable development. Just want to get a rough breakdown. It would help me a lot in terms of course planning. Because one thing I have to do as well is help plan sort of like a course. So if you're more say sustainable development, fine. Yeah. So I would like to see a little bit of a distribution so I can help plan the thing. So if you can help me with that. And also send me last week's class notes. Okay. So with that, it's been a pleasure. I'm sorry I've been very hard on some of you, but I hope you understand that that's a luxury, guys. I converted reinforcement learning problem into supervised learning problem. From now on, you will get that. If you behave in disrespect, people are just going to ignore you and not include you to any opportunity. You just be culled from the population without you knowing. So if you see any kind of lecture gives you a direct negative feedback, be thankful. That's just about the last opportunity you are going to get direct feedback. Most of the time, people will just make judgment without telling you. You just won't get the opportunity. Things will just go away. Girls will stop dating you. You come in late, you don't know why. Yeah. So girls are not going to say, I like you a lot, but you're not punctual. No, they won't say that. Yeah, they'll just not see you the next time. So be grateful when you get direct feedback. Okay? Because it's much easier to learn from direct feedback from reinforcement learning. Trust me, reinforcement learning is a very difficult research. Okay? So with that, I'm going to make my way. I have to run. And I hope everybody enjoy your summer and you are enthusiastic about this multidisciplinary journey as I was in your age. Okay, ครับสวัสดีลูกสวัสดีครับครับสวัสดีลูก Okay, I'll catch you later. You can come and chat. So this one is just one thing. They did whatever negative comments out, but then so I should have like 70. I'll check you later. Okay.